Alrighty, let's take a look at our first homework for the year for lesson 1.1.1. First, we start off with our M&Ms, which basically is showing us how to convert. Why do I have all this stuff on there? Let me just get rid of all that. Okay, how to convert from fractionals to decimals, percents, going back and forth between those representations. Recalling that any, let me go ahead and use this color, any fraction, say 3/5, can be converted to a decimal by doing the division. And if you take your calculator and you take 3 divided by 5, it gives you the decimal equivalent, in this case, 6/10, because that is equivalent to 6/10, correct? 3/5, 6/10. And then if you want to convert that to a percent, you can either multiply this times 100 so it becomes 60%, or you can take and do the whole giant one process. What do you multiply times 5 to give you 100? Remember, percent means out of 100. So once you convert this fraction to its equivalent percent, the numerator, no, let me rephrase that. Once you convert this fraction to another equivalent fraction over 100, the numerator becomes your percent. So 5 times 20, let me go ahead and write this in there nice and small, is going to give you 100. So we're going to take 3 times 20, and that will give you your 60. So really, these three are the important ones. Being able to draw the pictures and write out the words is great, but we want to be able to go back and forth between those representations. So to the degree that you understand how to go back and forth, it is in your best interest to record these processes just in case we get into a situation where you need to change a fraction into its decimal equivalent so you can plug it into the calculator to solve a problem. You need to know how to do that, and this all shows you those processes. Okay. All right, here we have some of those diamond problems, remembering that the two numbers, when you add them together, gives you the number on the bottom, and when you multiply them together, you get the number that's on the top. So 3 times 4 is 12, and 3 plus 4 is 7. And so when you're given these two numbers, all you have to do is the calculation. But when you're being given the other numbers, like for instance, this one right here, of course, that matches that. But you know, you're starting to think, what two numbers can you multiply together to give you 12? That when you add them together gives you 7. And so you think, well, it's not 1 times 12, because that would be 13. It's not 2 times 6, because that would be 8. But 3 times 4, that is the combination that works, because the product is 12 and the sum is 7. And then here you start getting into algebraic kinds of problems where you know 1/2 times something equals 4. So 1/2, call that x, is equal to 4. So what do you take half of to get you 4 for an answer? That would be 8. And then 8 plus 1/2 is equal to 8.5. So when we go through these homework problems, I'm just going to kind of briefly go through it because I don't want these to be 20-minute long videos. I'd rather have them 10 minutes or less. If there's a problem where you've got a question, you know, tomorrow when we are working on these problems in class, when we are, say, if we're doing distance learning, if we're having a morning meeting on Google Meet, then that would be the time to ask the questions, and I can pull these problems up and I can explain the process to you online. Or you can try and get a hold of me during office hours. That's always possible too. Okay, in this course, you will need to work with numbers, words, and geometric representations. Use each of these representations to answer the following problems. So draw and shade a figure, that's 100%, right? So whether you chose a rectangle, a square, anything, I chose a circle. When the entire thing is shaded in, that represents 100% of the circle. This should be half of the circle, 50%. This should be a quarter of the circle, 25%. And this would be 150% because it's one whole circle plus 50% or half of another. Write another fraction that is equivalent to 4/5. Well, if you chose your giant 1, you could have 8/10. You could have 12/15. You could have 16/20. There are an infinite number of equivalent fractions, but I chose 8/10 because that's easy to convert to its decimal, 8/10, which is 0.8, and then to the percent, which 8/10 is 80/100, so that would be 80%. And this is what the pictures would look like for that as well. Drawn shaded figure that represents 1/3. Now 1/3 is 1 out of the 3 shaded in, but the decimal equivalent's not as easy. That is 0.3 repeated. Or you could have written it as 0.333 ... meaning that that's going to go on forever. And then describe what the diagram at the right represents. Well, that's 1 out of 10, correct? So 1/10, 0.1, 1/10. Susan's apartment is shown at the right, assuming that all the rooms are rectangular. Find the areas. So the area of this bedroom is 10 by 15. The bath is 10 by 8. The living room is 18 by 15, and the kitchen is 18 by 8. So to find those individual areas, you just multiply those numbers together. The area of the living room has to be 270 square feet because 18 times 15, just to verify, 18 times 15 is 270. So to find the area, remember, area is always equal to the base times the height of your rectangles. Find the area of the entire apartment. Well, that's where we need to add these guys together. So this, I'll write it over here, is 28 total feet in this direction, and in this direction, it's a total of 23 total feet. So you can do one of two things. You can either take these individual areas and add them all together, or you can take your calculator and say, well, is 23 times 28 going to give me the same thing? And as a matter of fact, it does. So the total area of the apartment is 644 square feet. How much larger than her bedroom is her living room? Well, how much larger is a subtraction question, correct? So 270 minus 150 would be 120 feet bigger, 120 feet squared bigger. And then find the perimeter of the kitchen. Let's see, what is the kitchen? This is 8 and 18, another 8 and another 18. So when you add, what would that be? 18 and 18 is 36. Then you add 8 and 8, that's another 16. So when you add those together, that's how you get your 52 feet. Alrighty? Alrighty. And then for the last problem, compare these graphs and describe, compare, let me just read what it says. The following 3 graphs describe 2 cars, A and B. All right, so looking at this graph, this is 0, 0, correct? 0, 0, 0, 0. So as you go up, the amount gets higher. So B is higher up than A, so B is more expensive. And as you go to the right, that's the age that increases. So A is older than B. Here, A is the bigger car, B has the faster cruising speed. And here, B has the fewer capacity for passengers than A, but A will go further. That's the range, how far it can go. So the newer car is more expensive. Is that true? Car A is older than B. So is B more expensive? Yes, that's a true statement. The slower car, let's look at the cruising speed, would be A, is larger. That is also true, right? The higher up you go, the larger the car. So this is a slower car, B is the faster car. Larger car is newer. Well, this is where we have to take 2 different graphs. Graph A, car A is the same car as it is here. So no, this is the one with the older age, so it's not as new as car B. So the faster car is the newer one, the larger one is the older one. And then the cheaper car carries more passengers. Which one is cheaper? A is cheaper. Passenger capacity, A, yes, so that's a true statement. Okay, so there ends, and it's less than 10 minutes. Good job. So listen, make certain you're always doing your homework. I'm going to tell you right now that 8th grade math has a lot of review elements in the first half of the book. You're going to feel like you want to be more challenged. Please just go through the process. Go deeper with your understanding. If it all makes sense and seems easy to you, go for depth. Trying to find those nuances of why things work the way they work is really going to benefit you for when you get into high school. Once we get into chapters 6, 7, 8, and 9, and I think 10, The work gets a lot more complicated, I promise you. So get into your good work habits early when you think it's easier. Get your grade nice and solid, get it up there nice and high. And then if you start to falter a little bit later in the year, you're still going to have that work ethic and you're still going to have those the grades to help you out because you would have started off the year so strong. And I say that as if second semester grades don't start over in January. They do, but still, that my point is start off strong and then maintain that, and you're going to have a great, successful 8th grade year in math. Okay. And now I'm going to 10:30, and I'm going to stop right now. All right. Talk to you later. Bye.
Hey, feeling good, like I should. When in dark, walk around the neighborhood, feeling blessed.